We will discuss about potential energy of a system of charges. We will derive an expression for the potential energy of a system of three charges through one problem. The question says, find out the expression for the potential energy of a system of three charges Q1, Q2 and Q3 located respectively at R1, R2 and R3 with respect to the common origin O. R1, R2 and R3 with respect to the common origin O. We need to find out the expression for the potential energy of a system of three charges Q1, Q2, Q3 and their respective distances are given with respect to common origin. Let us derive this. First, we will draw the given situation. We have three charges Q1, Q2 and Q3. Let us say this is x-axis and this is y-axis. We'll take the common origin point as O. And charges Q1, Q2, Q3 are at its distances R1, R2, R3 from the common origin. So let us assume some distances. So let me say we have Q1 over here, and another charge here, and so we don't know which is distance is greater or smaller, so we'll just assume three charges. Let me say this is Q1 and this is Q2 and this is Q3, and Q1 is at a distance R1, Q3 is at a distance R3 and Q2 is at a distance R2 from the common origin O. So let the three charges are Q1, Q2. Three charges Q1, Q2 and Q3 have position vectors R1, R2 and R3. Position vectors R1, R2, R3. So we'll write it as vectors. Position vectors R1, R2 and R3. R1, R2 and R3 respectively. So these are the position vectors. We have derived the potential energy for a system which has two charges. So we'll use those equations to find out the total potential energy of the system. So consider Q1, Q2, write their potential energy. Consider Q2, Q3, write their potential energy, and then Q2, Q3. So right. So we'll write this. So potential energy of the charges Q1 and Q2. Potential energy of the charges Q1, Q2, Q1 and Q2 is U12. U is U12 equal to, so write the equation 1 by 4 pi epsilon naught into Q1 Q2 by R12, where R12 is the distance between R1 and R2. So if Q1 and Q2, let us say the distance between Q1 and Q2 is R12. R12. So here Q1 Q2 divided by magnitude of R12. So this can be written as 1 by 4 pi epsilon naught into Q1 Q2. R12 can be written as magnitude of R2 minus R1 vector. So we are taking only magnitude R2 minus R1. Similarly, the potential energy of charges Q2 and Q3. Potential energy of charges Q2 and Q3 is U13 or U23, 2 and 3. So U23 equal to 1 by 4 pi epsilon naught. Charges are Q2 and Q3. Q2, Q3 divided by the distance between them. The distance between 2 and 3, let us take it as Q2, 3. So Q1 and Q2 is R2, 3. R2, 3. So R2, 3 can be written as R3 minus R2. Magnitude of R3 minus R2. Difference between the two vectors. Similarly, potential energy of charges Q1 and Q3. Q1 and Q3 is U13 equal to U13 or U31. So we wrote 1, 2, 2, 3. So I'll write 3, 1. You can write U13 also, no problem. So 1, 2, 2, 3, 3, 1. U31 is 1 by 4 pi epsilon naught into Q1 Q3 or Q3 into Q1 divided by magnitude of R3 minus R1. So here the distance between 1 and 3, charges 1 and 3, R13. This is the vector R13. R13, R12, R23. Now the net potential energy of the system is the sum of this. Net potential energy of the system is U equal to U12 plus U23 plus U31. So you add all of them. U12 plus U23 plus U31. So U is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R2 minus R1. Q1 Q2 divided by R2 minus R1. R2 minus R1 plus Q2 Q3 divided by R3 minus R2, magnitude of R3 minus R2 plus Q3 Q1 or Q1 Q3 divided by magnitude of R3 minus R1. So this equation gives the potential energy of a system of 3 charges, where the charges are at a distance R1, R2, R3 from the common origin. U is 1 by 4 pi epsilon naught into Q1, Q2 divided by the distance between 1 and 2 plus Q2, Q3 by distance between 2 and 3 plus Q1, Q3 by distance between them.